So here's our state of sites now. We've got sites across Western Canada and into Ontario there as well, where we're measuring natural source zone depletion. We've also got some vapor intrusion and groundwater sites, but we'll be focusing on these soil sites. So we've measured NSAD at all of these. This is what the regional mean natural source zone depletion looks like from those sites. This is for January to January, so it's a calendar year. Now we've normalized it so that because sites are going to be higher and lower, but they're going to exhibit similar patterns through time. So we just want to be able to compare apples to apples. So that's why you see some negative numbers here. But we'll just look at the shape, and it's a little counterintuitive because if you read the literature on NSAD, normally you should be expecting to have peak in the fall, say September, October, but that isn't really the case. On average, it's actually more in the springtime. And so that's our regional mean. If we look at a couple of sites, we see overlaying the regional mean there that some of our sites show this. Okay, that makes sense. We are calculating a mean, but there are some sites that are completely the opposite. If we overlay that regional curve on there again, you can see they're doing the exact opposite pattern. Still potentially a peak in NSAD in spring, but just the variance through time is much different. And so this I think highlights why it's so important to measure NSAD at a site and not assume that you say, okay, it's going to be highest in the fall. We'll assume that we'll measure then. See, there's actually a lot of variability. So this is where point in time estimates might fall a little bit short of giving you an accurate site picture. And the bonus, if you're measuring both hydrocarbons and their biological indicators of depletion, you get two estimates of how depletion is going at the site. And there's a nice, relatively tight relationship. I've got to update this with our recent sites, but it's nice to see that NSAD is correlated with hydrocarbon depletion, which is what you'd expect. Okay, there's been a lot of buildup, Steve. Let's get to these models. So here's our three scenarios. On the left, we've got the baseline. In the middle, we've got, so baseline is where we're assuming NSAD is 0 because we haven't measured it. Here's where we have measured it. We've assigned it a non-zero value. And then on the right is the biostim. And this is, if we've got data at a site, we'll use those data, but based on averages across comparing biostim to non-biostim sites in our network, it's on average about a doubling of NSAD. So that's typically what this represents. And you'll see, hopefully it's not squinting too much, there's these light blue arrows. That's the groundwater flow. And then we've got these different isolines of groundwater concentrations of benzene. In this case, we've used, this is Alberta Tier 1 drinking water guidelines, it's 0.05 to delineate. And you'll see with the baseline scenario, the concentrations go down through time. You see the ticker going here. And that's mainly due to diffusion and dispersion. You're spreading out the same concentration over a larger area, so the concentrations are going down, but your plume is still getting bigger. With NSAD incorporating that depletion parameter, it's still growing, but it reaches a point, an inflection point where the plume actually starts shrinking. And biostim, see, this is a site where we did measure it. This is a nice success story where it actually is very effective, and that plume shrinks a lot quicker. So if you boil down the stats or the numbers from each of these, the time to stability, so that's when concentration and area are changing by less than 1%. Comparing your baseline, sort of your worst case scenario, to biostim, you've dramatically improved your time to stability by biostimming, and also dramatically reduced the total mass in groundwater. So as an outlook, for single site plan, you'd look, okay, this actually looks like a really good candidate to either start biostim or continue biostimming at.